In this segment, we are going to be going through adding polynomials and subtracting polynomials. But in order to subtract the polynomials, we're going to have to review our distributive law, so we're going to throw that in there as well. But adding polynomials. Remember, polynomials are just many terms strung together. In order to add polynomials, we can only add like terms. We cannot add apples to bananas. We can only add bananas to bananas. So we need to make sure that we identify what are like terms. Now, like terms are terms that are alike. No, that's a terrible definition. We need something much better than that. All right, so what are terms again? Well, that's that number, variable, or product of a number and variable separated by addition. Oh my, yep, keep repeating it until you remember it. So what makes those different terms like terms? And there's two criteria for like terms. Okay, the first criteria for like terms is that they have to have the same variable, or variables if we have more of one. Okay. So I cannot combine a term that has an x with a term that has a y because they're not like. They're not the same. But there's a second thing that you also have to look for. Not only do they have to have the same variables, but the variables have to have the same exponents. Now we talked about this in week 1 or 2 or something of that sort, and we've reviewed it several times throughout. So this is not anything new. We're just looking at it with the same variable, whereas earlier we looked at a's and b's as opposed to everything being an x. And now we're going to have things like x squared or x to the third power. Okay? All we need to do to add like terms, as it states up here, is to add the coefficients. Add the coefficients. If we're going to do all this work to make sure that we're only combining like terms, and like terms have to have the same variable and the same exponent, we will not change the variable or the exponent. We will not change variable or exponent. When adding like terms. And the same thing will happen for subtracting. So we're going to do all this work to combine like terms. We don't change the variable or the exponent. That is what makes them like. We only add or subtract the coefficients, or the numbers in front of those. So here we have an example of this big, long, scary-looking thing, which should not be so scary. What's happening here? Why are all those parentheses in there? I have to do what's inside parentheses first. Yes, but inside parentheses we have this polynomial. Those terms are not alike, so I cannot combine them. And then I'm adding another polynomial. So the reason for the parentheses in this chapter is to identify our polynomials. So I have one polynomial over here, I have another polynomial over here, and what's in between them is the operation that we are going to be performing. In this case, we are adding. So because I know my answer needs to be in standard form, which is the highest exponent first, what I do first is I scan all my exponents and look for the largest one. I see I have an x squared and an x squared. There's nothing higher than that. So x squared is my highest exponent, so that's going to be the first term. So now I go through and use different colors and use different ways. I underline them 2 times for the x squared, and here's a 2 times a line underneath it for the x squared. Those are the 2 like terms that are x squares. I have 7x squared, and I'm adding 2x squareds. That gives me a total of 9x squared. Notice I did not change the variable or the exponent. Now I go to my next term. Because we started in the highest exponent, you just go in decreasing order from there. So the next thing I'm going to look for is an x. Here's an x. Here's an x. So I have 2x plus x. What is that going to give us? what's the number in front of this x? The coefficient is 2. What's the coefficient on the other x? Can't be 0 because what's 0 times x? 0. Then I wouldn't have an x there. What would make that x come back? Ah, God of Mathland once again shows its wonderful face. It's 1x. So we have 2x plus 1x, which makes a total of 3x. Now we need to separate that term from the 9x squared. How do we separate terms? By addition. It's still a positive, so we go plus 3x. Now we go to our next term. In decreasing order, well, since x doesn't go any smaller than that, we then look for the constant, that's our caboose, and I have an 8 over here, and what's over here? Oh, remember, the sign in front of the term goes with the term, so that's a negative 9. What do I get when I add a positive 8 and a negative 9? 8 take away 9 gives me a negative 1. You can write it as that, subtraction, or you could add a negative 1. But you need to separate that term from the previous term by either adding or subtracting. I cannot go any further as x squared is not the same thing as an x, which is not the same thing as a constant. So this is my answer, and that's okay. When I have a polynomial and I add another polynomial to it, my answer is going to be a polynomial, or several terms together, and that's okay. One of the things that we always feel is that we have to go down to a single number. Oh, I need an answer. No, we're not finding an answer. We're not solving anything. We're just simplifying stuff right now, gathering the like stuff together. As I said before, I think of this as a choo-choo train. And then each of the variables and the exponents represents a different train car. So here maybe x squared is the passenger car. And here I had the hopper car. And here's the constant caboose. Well, I had 7 orders of people in my passenger car, and I added 2 more. That gave me 9 that's still in the passenger car. So the name of the car didn't change when I added more to it. I had 2 loads in my hopper, and I added a load. Now I have 3 loads in my hopper. You don't put loads of people with junk that goes in the hopper car. The people get pissed off. So you can't travel together there. Okay? The same thing, you don't put the scrap metal that belongs in the hopper car in with the passengers. They don't return. They're not happy. Okay? So keep that in mind. And then the constant caboose, those don't go anywhere else. They just like to hang out at the end. Okay? So that is how we're going to add our polynomials. You simply add the coefficients of like terms. Now before we subtract like polynomials, or like terms of different polynomials, I want to make sure that we review the distributive law. It's going to help us remember the steps that we need to do in subtracting polynomials. So remember, the distributive law is stated something like this, that we have a number in front of parentheses, and inside the parentheses we don't have like terms. I can't add 3 to x since I don't know what x is. We can't just put a number in there. We don't know what it is. It could change. That's why it's called a variable. It can vary. But I do want to get rid of those parentheses. And so the other reason for parentheses is to indicate multiplication. So the 2 is being multiplied to that result. Well, we distribute the 2 by multiplying it to both terms inside to get our answer. So we would have 2 times x plus 2 times 3. And then we'd simplify it. We don't really use the multiplication dot between a number and a letter because just mushing them together means multiplication. And 2 times 3 we know is 6. Once again, those 2 terms are not like, so we cannot combine them or go any further. Okay, well that's not so bad. Let's do another one. Negative 4 times the quantity of x minus 6. Same idea, negative 4 gets distributed inside. Negative 4 times x is a negative 4x. Negative 4 times, remember the sign in front of the term goes with the term. So it's a negative 4 times a negative 6. Multiplying 2 of the same sign is a good thing. And so it's plus 24. Once again, those are two different terms. They're not like, so we cannot combine them. Well, that seems pretty easy. Negative 3 times 5x, negative 15x, negative 3 times a negative 1 is a positive 3. Once again, the first term has an x and the second one does not, so those are not like terms. I cannot go any further, and that's okay. That seems really easy. All right, let's do one more just for kicks and giggles. How do I simplify that one? Uh-oh. Yeah, we can still do that. What's the number in front that's being distributed in? The god of Mathland, he, she, it, is always with us. So it's just a negative 1. Now what happens when I multiply a negative 1 to a 2x? Negative times a positive is a negative. Negative 1 times this negative 7, negative times a negative is a positive 7. So the negative sign out in front is saying to take the opposite of what's inside your parentheses. So the 2x was positive, it becomes negative. The 7 was negative, it becomes positive. It just changes all of the signs inside. We're going to use that concept in order to subtract polynomials. To subtract polynomials, we need to remember that subtraction is the same thing as adding the opposite. We like to call that change. So you see in this example we have 3x squared plus 5x minus 4. Once again, that's in parentheses indicating that that's the first polynomial. We have a second polynomial in this parentheses over here, the negative 4x squared plus 11x minus 2, but this time we are subtracting. Now you need to remember that you are subtracting every term in this second polynomial. That gets a little bit confusing, and when we have negatives in here, then we have the tendency to forget that we're subtracting the negative. So we're going to do a different procedure, which is going to be a whole lot easier for us to remember. We're going to use, once again, that change, and the idea that we just went through about distributing through a negative. Because if you look at this problem and I take away or I cover up the first polynomial, the result that we have there is exactly like that last distributive property example. So we're going to do that same idea here as your first step. I'm going to do change. Okay? I like to say, okay, so the subtraction I'm changing to addition, and then the sign of the number right after I change. Well, the number right after is a 1, because remember, it's 1 that would be multiplied inside. That 1 is positive, so I'm going to change it to negative, and that's my second change. Remember, the first change is to go from subtraction to addition, and the second change is the sign on the number right after the subtraction. If it's positive, it goes negative. If it's negative, it goes positive. So now I see that I have a negative 1 times this quantity. According to our order of operations, we have to do the multiplication before we can add or subtract like terms. So my next step is to distribute through this negative sign all the way to every term inside the second polynomial. I did not do anything with the first polynomial, so I won't change any of that. That's still going to be 3x squared plus 5x minus 4. But now we distribute. Negative times a negative makes it a positive 4x squared. Negative times a positive makes it a negative 11x. And a negative times a negative makes it a positive 2. Make sure you are multiplying, don't start adding things. Now, because it's all addition of terms, we don't need the parentheses. So now we can go through and we can combine our like terms. So the highest exponent we look for first. That's a square. Here's a square. Here's a square. 3x squared plus 4x squared is going to give us 7x squared. Then you look for your x terms. Here's a 5x. Here's a negative 11x. Remember, the sign in front of the term goes with the term. That's why I underline it to go with it. 5 and a negative 11 ends up being a negative 6x. You can use that negative as a subtraction to separate your terms. And then you have your constant terms. So we have a negative 4 and a positive 2. One of each sign, we subtract and keep the sign of the larger. So we would go 4 minus 2, which is 2. The 4 is what we started with. It's negative. So our result is negative. Once again, I cannot combine a square with an x with a number that doesn't have a variable, so I'm all done. That is my new choo-choo train. Choo-choo. Here's another problem. Here I have 6x cubed minus 4x squared minus 3x, and I'm subtracting the polynomial of 8x squared plus 5x plus 2. I would pause it now and see if you can work this one through yourself. Okay, let's see how you did. First of all, I would do change. Now, I've done a lot of these changes through my time, and I've realized that I can even do a shortcut, which is even faster than what I did on that last problem. Last problem, I kind of showed all my distributive property, which is fine, and if you're at that stage, do it like that. Don't make yourself make silly mistakes because you're trying to rush your understanding. But I know that I'm going to change this, and then I move it inside, and I change all of the signs inside. So I'm just going to distribute that negative all in one. I'm going to make this negative, or the subtraction, into a positive, so I remember that I'm separating terms still. And then I go inside the parentheses after that subtraction, and I change all the signs. This is a positive 8x squared, so I make it negative. This is a positive 5x, so I make that negative. And a positive 2, so I make that negative. If any of those were subtraction, I would make them into addition. And now I've dealt with my change, and I can simply go through and combine my like terms. Once again, I look for my highest exponent first, and I notice that I have an x to the third. Oh, but I don't have any other x to the thirds. So that term, still part of my answer, but I don't have anything to combine it with. It's my highest exponent, so to be in the standard form, I put that term first. Now I go through and I look for my squares. Once again, the sign in front of it goes with it. So I have a negative 4x squared and a negative 8x squared, and we're adding, remember now? So in adding like terms, they're both negative, add them and keep the sign. So that would be minus 12x squared. Then we go for our x's, and we have a negative 3x and a negative 5x. Same idea here, they're both negative, so keep the sign and add the numbers together because we are adding. But then don't lose your constant. The caboose has got to come along. Well, there's no constant over here. Well, that's all right. It comes along just like the 6x cubed did, but don't lose the sign on it. It's a negative 2. So you can either put plus a negative, or I just call that subtracting 2, because adding a negative is the same thing as subtraction. And here is my polynomial result. So when subtracting, remember to change all of the signs in the second set of parentheses, or the parenthesis after the minus sign. Change the minus sign to plus, and change all the signs inside to the opposite of what they are. And then combine your like terms.